Hello, everyone. I hope everyone is doing good. Today, I'm going to show you a project I built from scratch, which is an AI-powered chatbot specifically designed for people to understand Alzheimer's disease, whether it's people who are just curious, the caregivers, people who want to do a bit of research, whether you're a family member of someone living with Alzheimer's, or you're just curious of how the disease works. This app gives you a conversational way to get real information and answers. And what makes it interesting is that I actually trained it and compared it with different deep learning models to achieve the best results for the specific tasks. So in this video, I'm going to walk you through the live app project structure, how the front end works, how the hyperparameters have been tuned and the experiments, the BERT model and everything. So come along. Um, so this is the app interface, the sidebar here. Um, You can see a clean interface, the sidebar on the left and the conversational um, chat here in the middle. There's a history section here where you can add a new conversation. The design uses a warm brown and orange color for the AI responses. For example, if you could check a new response, for example, what are the early signs of Alzheimer's? You can see the typing indicator when the model is generating a response, and there it is. It gives a clear, informative answer in plain language. Let me try another one. How can I support a family member with Alzheimer's? How can I support? There it is. Supporting a loved one with Alzheimer's involves creating a safe space, a supportive environment, blah, blah, blah. You can also see the conversation history here on the left side and the status indicator. Um, so this is the full this is the full end-to-end product running on Flask backend and the front end, which is HTML and CSS. I'll take you to the VS Code to see the project structure. And here we are. The the folder is called chatbot here. And inside that chatbot, we have the backend folder and the front end folder and the model and git ignore. All this was for a previous project that I had duplicated in the same screen. If we open the backend, we have Conda for my source environment. We have the app where the whole thing is running. We have a copy of the collab that I got because I could not properly download the proper version of the collab. We have the data. Here is the data. We have 18,000 questions, 18,000 plus questions. How many are they? 18,602. The model evaluations for the pre-trained model according to Blue and Meta. And all these are test examples. We have, this was just to log into Hugging Face. We have the hyperparameters starting from the different models that we trained because we trained a baseline model with embeddings 256 and the density of 2048. These are the results from it. We also did a larger model with 512 as the embedding and a dense model of 4,000 plus, and these are the metrics. All that all the way up to the last model that we trained, which was the BERT. We also have a file for the pre-processing where we had 18,500 samples, total samples. How many unique words were there? What was the maximum length? What was the average length per question? And then the target, which is the result prediction, the average length of characters, what are the missing values? There was 0 missing values, but there were 2,000 duplicates, which we removed. So when we removed the 2,000, we now have 15,000 samples. And these are the samples of the cleaned version. We also normalized the text. We had an empty filler. We filtered the length, and we saw the reduction in the text content was by 18%. We also have a requirements.txt file, which has the different requirements for the backend. And this best BART file here is what we got from the torch that we used to train the BART model, right? So I'll go to the front end now, and you'll just see the structure. The structure is simple. We have a HTML file with everything, a JavaScript file that is loaded with the API URL from whatever we have in the app.py, and then we have a CSS file, basic. Yep. So let's get into it, starting from the HTML file. Let me walk you through the whole API index.html, which has a sidebar and a main chart section. Just that basic. The styles, they were different just to make sure the color is right, the fonts are right, the alignment is right, and all that, right? On to the best part. We're going to dive deeper into the whole model creation. And for that, we are going to switch to Collab. Now let's talk about how we did the hyperparameters tuning. Here is the hyperparameter part. Just a minute. Here. We were using the same F1 score. We were using the same metrics to just get everything aligned according to 1, the accuracy, 2, the loss, and 3, the F1 score, because we want to capture as many false negatives and false positives as possible. These are the models I trained, the one with a higher, the baseline model with 256, with a higher learning rate, with a lower learning rate, and all that. And you can see the training here, which the basic model had only 0.01 as the accuracy, validation accuracy. This other one had 0.14, and the last one had 0.09. When you go to the pre-trained model, we did it in 2 ways. We started by the encoder model, and then we went to the decoder model. So for the encoder model, we were thinking about the end of statement, EOS, pad token ID, and vocab size, which we were getting from the BART methods. And then we did tokenization here, which we had done tokenization, but for custom models, the ones that we were changing, the different, how are they called? Parameters. Yeah. And then we saved our model here. And here's a comparison, or here's the training of the model. And here is the comparison. So our validation loss with 3 epochs was lower than more than 30 epochs of the baseline models. It was 500% better. Our model was 500% better. The BART model was 500% better than the baseline model. And these are the normalized metrics comparisons here. How did we evaluate the metrics to see how good our model trained? So we used Blue and Netwa, and you can see here by the scores and the distribution how good our metrics was. It leaned towards the lower side of the Blue, and it also leaned more towards the lower side of the Metro, but you can see the distribution here in the comparison. The model analysis. Question 1, should individuals with a history of inflammatory bowel disease avoid vitamin D supplements? What does it say? Consult a gastroenterologist. We could ask the same question to our model again and see if our model has improved. Same thing. Ask a gastroenterologist to determine the personalized vitamin D recommendation, which was here, which is the reference here. How does nicotine affect the levels of extracellular vesicles in the brain, and how does this impact the mechanism of the intercellular communication that may play a role in Alzheimer's in pathology? And just copy this again, and we will see how our model predicts how good. Same thing, investigating how Nico something, and it has this blue results. Overall, our model did pretty well. I would not say that it would overrule the medical practitioner's advice, but it definitely gives you some bit of information about Alzheimer's.